All right. I think that creating a new project is going to be the way to go here. We get these to experiment a bit with the marching cubes. Create. Call this main. What do I use to create the shape? I made this game. Going by the lighting, it looks like Unity. Oh wow, look at that. That's cool. Oh my god. Wow. What happened to this game, do you think? Sunburn. No, it's not the same. meshing algorithm and also provide the triangulation tables. All right, let's go. What's up, bro? Happy Friday, man. How are you? This feels solid. It's an article from 1994 about marching cubes, so it has stood the test of time. The document. Who is this guy, by the way? 61, which country is that? Is it like Australia or something? Yeah, Australia. Donate. Can of beer, bottle of wine. Nice. Okay. The week? Yeah, it's been good. It's been good, man. It's been... it went by pretty fast. And I had some real life obligations, so that's why I haven't been able to code as much as I otherwise would have done, or otherwise would have wanted. And your week, how was it? Document describes an algorithm for creating a polygonal surface representation of an iso surface, a 3D scalar field. So many words. Marching cubes algorithm. Simplicity and high speed. That's good. That's going to be needed. A lot of schoolwork. Got it, got it. What are you studying? There are many applications for this type of technique. Two very common ones are medical volumetric data sets. MRI scans result in a 3D volume of samples at the vertices of a regular 3D mesh. Mathematical scalar field. In this case, the function is known everywhere, but is sampled at the vertices of a regular 3D grid. Edge index, vertex index, okay. Okay, but are you on like what's the subject matter, like on a high level that you're studying? Like what's the program, or is it just, if you say schoolwork, I guess you're in some kind of school, or is it free time studying for fun? Approximation to an ISO surface. I need to know what an ISO means. No, not this ISO. Equal values in a 3D data distribution. Studying for exams and stuff. Okay, cool. English, math, geography, history. Nice. Well done. That you spend time studying. That's good. So what do you want to... What do you want to specialize in, do you think? If anything. ISO line. Okay, I think I kind of get it. Contour line. Yeah, so it is kind of like derivation and yeah, calculus. You're kind of moving towards the limit. Like the smaller steps you make, the more closer to the actual shape you're getting or something. Planar facets not be passed through any one of the vertices, or it may pass through in any one of a number of more complicated ways. Each possibility will be characterized by the number of vertices that have values above or below the ISO surface. Yeah, and I guess that could be a noise map, like a three-dimensional noise map, for example. If one vertex is above the ISO surface, say, and an adjacent vertex is below the ISO surface, then we know the ISO surface cuts the edge between these two vertices. The position that it cuts the edge will be linearly interpolated. The ratio of the length between the two vertices will be the same as the ratio of the isosurface value. What the heck? The ratio of the length between the two vertices will be the same as the ratio of the isosurface value to the values at the vertices of the grid cell. I don't understand this sentence. Spanish possibly, taking a lot of time to consider it. Okay. Cool. That sounds fun. What I'm gonna use this for? Yeah, so I was thinking it would be cool to create a like three-dimensional world, so I don't just have this surface, but I also want there to be like caves and stuff underneath, and I also want the player to be able to like dig holes and make tunnels and stuff. So to do that, I think I need to refactor how this is working, because now it's just a surface. I did some research the last few days on like how it's done for Minecraft and some other games, and this seems to be, I don't know about Minecraft when it comes to marching cubes. I think there it's a bit easier because you just have cubes, but yeah, if you want it to be non-cubic, you kind of have to do it like this, I think. And this is also going to be pretty cool, because then like if you make too much of an overhang, let's say in your tunnel or like in a cliff, you can actually probably have some calculations and then just make this fall, for example. Cool. Values above, below. Wait, 1, 1, 2, 2, oh, 3, 3, 0, 0, okay. 4, 5, 6, 7, 8, 9, 10, 11. Okay, yeah, there are more edges than corners, of course. If the value, for example, the value at vertex 3 is below the isosurface value, and all the values at the other vertices were above the isosurface value, then we would create a triangular facet which cuts through the edges 2, 3, and 11. The exact position of the vertices of the triangular facet depend on the relationship of the isosurface value to the values at the vertices 3, 2, 3, 0, and 3, 7 respectively. Oh, wait a minute. Triangle. Relationship of the isosurface value to the values at the vertices 3, 2, 3, 0, and 3, 7. Okay, so there's like a scale there that it applies, I think. Oh. What makes the algorithm difficult are the large number, 256, of possible combinations, and the need to derive a consistent facet combination for each solution so that facets from adjacent grid cells connect together correctly. The first part of the algorithm uses a table, an edge table, which maps the vertices under the isosurface to the intersecting edges. An 8-bit index is formed where each bit corresponds to a vertex. 8-bit. So that's a byte. Cube index 0. Wait, if grid.val 0 is under... Oh, you check it at these 7 places. Yeah, the 7 corners. Oh, cube index. All right. What does this mean? Which language is this? Bitwise OR. It's probably not Java. I think it's probably C. An OR operation and assignment. X OR equals 3 is equivalent to X equals X OR 3. And what would that be? Use it quite often with Unity in the past. Hey Studio. Malaka, what's up? All right. The pipe equals, yeah. So I guess this is... oh, okay, I think I get it now. So it's either finding a cube index... No, wait a minute. If... Yeah. So I guess... it gets this value or that value. If this is under the ISO level, this is going to be true. Or maybe it's plus equals here. Let's see what he says in the text. Looking up the edge table returns a 12-bit number, each bit corresponding to an edge. 0 if the edge isn't cut by the ISO surface. 1 if the edge is cut by the ISO surface. If none... Oh yeah, 12-bit number, there are 12 edges. Okay. If none of the edges are cut, the table returns a 0. This occurs when cube index is 0. all vertices below the isosurface, or 0xff. That's 12, I guess. No, it's not 12. 258 maybe. $255, yeah, so that's the max. There's 256 different possibilities, yeah. It's basically setting bits, yeah. Seems like it. Using the example earlier, where only vertex 3 was below the isosurface, cube index would equal... Okay, I think I'm starting to get it now. So this is number 0, 1, 2, 3, or 8, yeah. Edge table 8 equals... wait a minute. Okay, yeah. Then we get the edges. So number 8, we have a lookup table, then we get the edges. And that is edge 0, 1, 2, and 3, and 12. 2, 3, and 11. 0, 1, 2, 3. Yeah, it's 11, of course. Okay, so there are lookup tables all the way, I guess. Or maybe this is the lookup table. Yeah, could be. That could be the case. No, I don't think so. The intersection points are now calculated by linear interpolation. If P1 and P2 are the vertices of a cut edge, and V1 and V2 are the scalar values at each vertex, the intersection point P is given by P plus iso value minus V. What's iso value? Scalar values. What do they mean by this? Scalar values. The last part of the algorithm involves forming the correct facets from the positions that the isosurface intersects the edges of the grid cell. Again, a table, tritable, is used, which this time uses the same cube index, but allows the vertex sequence to be looked up for as many triangular facets as necessary to represent the isosurface with the grid cell. There are at most 5 triangular facets necessary. This is cool, how you can see how the resolution increases. What I found so far, I'm starting to doubt my own capabilities a bit. I'm like starting to read some math formulas here, and I'm not really following what's going on. But I think it's possible. Back to our example. So this is kind of what you can do. You have some... Oh, we see some source code here later. Oh yeah, there's a lot of lookups. Wow. Yeah, I don't think I will create this lookup table by hand. It's great that someone has done it before. Small cracks. Summary, details. Vertex normals. Yeah, it makes it smoother. Wow. Tetrahedrons. This document describes an algorithm for creating a polygonal surface representation of an isosurface through a 3D scalar field, closely related to the so-called Martian cube, except in that case the fundamental sampling structure is a cube, where here it is a tetrahedron. It doesn't seem to be that complicated. It's all this is all. But let's read through it all. The previous step we calculate the intersecting points along edge 2, 3, and 11. The 8th element in the tritable is 3, 11, 2. The 8th element tritable, edge table. Okay. Is that the list here? 2, 3, 4, 5, 6, 7, 8. Yeah. Tritable. Edge table. Yeah. This is a particularly simple example. Be assured that the facet combinations are not so obvious for many of the cases in the table. Another example. Let's say vertex 0 and 3 are below the isosurface. 0 and 3 are below. So that means it should go like this, I guess. Cube index will then be, yeah, the 9th entry into the edge table is 905 hex. Oh, 905 hex. Which, why is it that? Oh, into the edge table. Let's check. Oh, so it's some hex number, yeah. Means edge 11, 8, 2, and 0 are cut. Ah, right. Yeah, we get these numbers here. That's so cool. 0, 2, I don't know exactly how this works, but it seems to be consistent. So we work out the vertices of the intersection of the isosurface with those edges. Next, 9 in the tritable. What do we use the edge table for? Even is 0, 11, 2, 8, 11, 0. So these are two triangles, I guess. 0, 11, 2, 0. Wait, the edge is 0, 11, 2. That's 1. And then I guess the next triangle is going to be 11, 8, 0. Yeah, 8, 11, 0. Cool. That's awesome. This corresponds to two triangular facets. He calls it facets. I think now people call it face or surface. But I guess that's a synonym. two triangular facets, one between the intersection of edge 0, 11, and 2. This is familiar notation. The other between the intersections along edges 8, 11, and 0. One very desirable control when polygonizing a field. Hey Morgan, what's up? What's up? How are you doing? One very desirable control when polygonizing a field where the values are known or can be interpolated anywhere in space is the resolution of the sampling grid. This allows coarse or fine approximation to the isosurface to be generated depending on the smoothness required and or the processing power available to display the surface. I'm good. Happy Friday. Processing power available to display the surface. The following example is of two Bobby molecules. Ah, so these are molecules. I thought this was like a bowling, whatever they're called, the things you make fall when you bowl. The following example is of two Bobby molecules as specified by Blinn, generated at different grid sizes. All right. Let's try to reproduce this then. It's going to be a long weekend for me. I have my final test in physics first thing Monday morning. Not looking forward to it at all. That sentence started off so well. It's like gonna be a long weekend, but then yeah, but then it's over, right? Just have to persevere for the weekend. Grind some hours. Yeah, it took a turn for sure. I'm just going to read the source code once again so I understand what's going on here. Or attempt to understand what's going on here. Type def struct xyz. Yeah, a triangle. I don't know what this notation means, P3, but I guess this is a vector. P8. And then a value, 8 values, and then grid cell. Grid cell. Given a grid cell and an ISO level, calculate the triangular facets required to represent the isosurface through the cell. Triangular facets required to represent the isosurface through the cell. Return the number of triangle facets. The array triangles will be loaded up with the vertices at most 5 triangular facets. 0 will be returned if the grid cell is either totally above of or I guess totally below the ISO level. Alright, yeah, then it's not gonna create anything. Int polygonize takes in grid cell, an ISO level, but that's just double. Triangle, triangles. I and triangle. Cube index, vert list. What's a grid cell? I still don't understand that part. Is that the cube? But the cube has 6 and then 12 values. These are the edges, vert list. And then you take in the list of vertices into the edge table, and then you take your value from the edge table into the try table, and this is where you get your triangles. All right, so they are just in order. 1, 2, 3, 1, 2, 3, 1, 2, 3, and then there is nothing. Okay. And then we need to figure out at what position in the real world and offset them these edges are, and translate that into vertices or vectors that we then put into our mesh. Determine the index into the edge table, which tells which vertices are inside of the surface. Yeah, this thing. Find the vertices where the surface intersects the cube. Wait. Why does he do this? Cube index. Linearly interpolate the position where an isosurface cuts an edge between two vertices, each with their own scalar value. Okay, that's what's happening here. Ah, wait, edge table, cube index. What did we get here? Int edge table. Where the surface intersects the cube. Okay. Try table cube index. It's not 1 minus 1. I plus equals 3. Yeah. Triangles and triang P0, 1, 2, 3, 0, 1, 2. Vert list, try table, cube index I plus 1, I plus 2. All right. Linearly interpolate the position where an isosurface cuts an edge between two vertices, each with their own scalar value. Isn't that a repetition of what I just read? No. Oh yeah. Vertex interp, iso level. What is XYZ? I guess that's a vector. C XYZ type. Geometries. I'm guessing that's the data type. Overview by Matthew Ward. Marching cubes is an algorithm for rendering isosurfaces. Define a voxel by pixel values less than the user specified ISO value and one or more values greater. The voxel must contribute some component of the isosurface. By determining which edges of the cube are intersected by the isosurface, we can create a triangular patches which divide the cube between regions within the isosurface and regions outside. By connecting the patches from all cubes on the isosurface boundary, we get a surface representation. Two major components. The first is deciding how to define the section or sections of the first surface which chop up an individual cube. If we classify each corner as either being below or above, there are 256 possible configurations of corner classifications. Two of these are trivial, where all points are inside or outside the cube, does not contribute to the isosurface. For all other configurations, we need to determine where along each cube edge. Yeah. Apply this process to the entire volume. Okay. All right. So let's start by creating a noise that we will try to represent in this 3D world. Export. Noise, let's call it like noise 3D. And that should be a fast noise light. On ready. Identifier in class body. Oh, var. There we go. New fast noise light. I just learned that simplex is better than... Hello Arch, how are you? Simplex is better than Perlin, I learned, because it's more natural. Like Perlin is quite square in its patterns. So it's gonna be based on the grid. It's gonna kind of follow the grid, while simplex is a bit more random in its directions. What you coding? I'm coding, trying to learn about marching cubes as a way to represent three-dimensional shapes in the terrain, so I can add like caves and stuff. Okay, this is good enough. Let's say I'm gonna have to give a constant, like what's the range, by the way, of the values we get from the simplex function? Simplex value range. scales, higher dimensions, O(n) squared for n dimensions instead of O(n) 2 squared of classic noise. Is that worse? Oh yeah, it's up to the power of n. Anyway, I don't think it really matters. Okay, let's see here what people get. Get values in a range of -1 to 1, -57 to 57. All right, let's just say that 0 is the base value then. And that could also be an export. Var noise. What did he call it in this article? Let's use the same terminology. Yeah, the surface is at 0. So this is going to be a float. And we can set it to why don't I see it? Oh, paths. We can set it to 0. When I tried to use Perlin, it basically generated tiny hills. Yeah. But that's good, right? Or you mean in a bad way? All right. So we have set the isosurface, we have set the noise. In a bad way. More chaotic terrain, more interesting. Yeah. It's very true. It's an art to make that right. I mean, if you look up how Minecraft is doing it, or I saw someone on X today doing a cool thing. This guy. You can make it really advanced. Like, look at this. Like how many layers of noise it is. Different layers with different resolution, different tasks. And that creates a complex chaotic terrain. That's extremely cool, I think. Let me share in the chat on Twitch. Copy the link. Wait, okay, that didn't work. Yeah, let me post it in the YouTube chat as well. Oh, this is the wrong YouTube studio. Yeah, whoa. Cool, right? Then cube size for cube. Yeah, cube size, we can call it that. Very complex, but it works, yeah. And Minecraft is apparently similar. There's like 20, 30 layers deciding different things. Like biome, and then the terrain, and the lakes, and the oceans, and the islands, and it just all comes together in a deterministic way based on the noise. It's very cool. So we can make cube size to 1, let's say. Ah, rounding errors. Great. Or float precision errors. All right. And let's maybe start with like 2 by 2 cubes. X width, float, export, sed, length, and then yeah, it's not 2 by 2, it's 2 by 2 by 2. So it's 8 y height. Oops, cancel. So let's do 2, 2, 2. Trying to make the terrain blocky? No, not really. I just want the, like in the previous game, everything was, you know, just on a plane, like you can just walk on top of the terrain. And like in a earlier version of the game, the player could dig, but you could only like make the surface go down like that, but you could never break the surface. But with this algorithm, with the marching cubes, you could potentially like build a cave, and there could be holes in the ground and stuff that you can discover. So that's what I want to do. Like that's going to enable more terraforming for the player, more interesting terraforming, more interesting environment. That's the plan. Yeah. So I saw this is a guy who wrote on Reddit. This is an example, if you see here. He can kind of terraform the world in 3 dimensions. He can like cut holes in the cave and create cave. Yeah. So yeah, that looks very promising. And he recommended this article I'm reading here. Okay, so for every cube that we march, we're gonna do for x in range x width, or z in range z length, or y in range y height. Maybe size is too much for now. I can add that later. It just adds unnecessary complexity. It's just going to be 1 unit for now. Maybe we need to use a 1. Then it's going to be better to at least use a constant cube size float. No, equals 1. End statement after constant declaration. Maybe since it's a constant, I don't need to specify that. Is the margin cubes for just the generation? The mining and stuff won't really be changed. I mean, the margin cubes, it's not, I mean, it's a way to represent what you have generated in 3 dimensions instead of just like a surface or like a top level surface. And that's also what's gonna enable the mining and stuff. What do you mean the mining and stuff won't really be changed? I didn't really follow. And then let's create a function for this. Oh, ISO level. That's a better name. Oh, we need to pass here. This is not compiling. ISO level 1. No, 0. So the margin cubes is an algorithm to generate a table with all the world data as voxel data. Yeah, kind of. So it's basically turning, here is a, like you have a 3D model of molecules, and then you run the margin cubes over the model, and then it figures out where in every cube it checks for where intersections between the thing that is the model and the cubes, and then it creates triangles on the surface area. So it's a way to create a mesh based on a like density model or something like that. Hopefully I can make it work, and then it can become more clear for us both, or for us all. Yeah, so let's create a function for this. Grid val. What are these 8 grid vals though? Oh yeah, it's every corner. Yeah. And how is he doing that down here? So if I understand correctly, yes, exactly. It's going to make it easier to make and edit. And like it's going to make it easier to enable the player to terraform it and like dig, and yeah, it's gonna enable a more three-dimensional, more interesting world. Be right back. All right, I'm back. Okay, so we're looking in the code here, trying to figure out. Welcome back. Thank you, man. Such a nice crew here. So wholesome. Where does grid values come from? Grid. Oh yeah, it comes from the grid cell and then val. All right. Okay, I get it now. Now I understand. Now I get what this struct is doing. It's what we do. Yeah. Now I understand, finally. Okay. So the grid cell, it is a cube, and it has 8 corners, and all of them have a vector each for its position. And all of them also have a ISO surface value. So in this case, it's going to be a value from the noise map. And that's what we then will take through this algorithm. Now, oh yes, now the final piece fell into place for me here. Okay. Makes sense. Yes, grid val, bam, 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 and then we're gonna do some grid, take the grid positions later. Okay, this piece I still haven't really understood yet, but yeah, P0, P1, try table. Yeah, we'll get there when we get there. Cool. So pieces found, assembly began. Yes, now let's start assembling. Guess we can call this March, no, check, no, evaluate. Polygonize, that's also something we could call it. Naming is important. And that's why it just needs one ISO level number, because that's what you compare with. Why are you sending in triangles though? How are the worlds going to be stored? As a file like in Minecraft or on some sort of servers? I think it's going to make the implementation a lot easier if I avoid storing any kind of servers. Potentially the players could choose to host, like set up their own server and host the game for friends, or like buy some hosting or something. But I think both like local and online or LAN play would be ideal. Okay, evaluate read cell. And then we can do x width, z length, y. No, let's do vector 3. It's much cleaner. X width, z length, y height. And then time to create this function. Adding PvP. I mean, I haven't even created the environment yet, but it's good to think far into the future. Yeah, I think PvP could be fun. However, I think that's probably not the main way to play a game like this. I think it's probably more like collaborative. I know, right? It's really good, this page. I can send it in the chat. It's amazing. It explains this complex concept in a very short and concise way, like very clearly. All right, so now we are in one of the cubes and we're gonna evaluate it. And this is where the magic starts happening. Evaluate read cell. Height. Yes, this should compile. Oh no, vector 3. I'm not thinking. It's enough that I do position. Okay, that's what. No, this is the internal concept. Let's call it XYZ. Is this stream going to be available to watch later, recording or whatever? Yeah, either on Twitch, but I'm also streaming it on YouTube, and I think the archival on YouTube is better. So I can send the YouTube channel. I think that's the link. Yeah. So here you can find like a lot of live streams. Oh my god, there's so many now. From me streaming Godot. It used to be some gaming. But now Godot is definitely a majority. That's nice. Do you have two chats? Yes, I do, Arch. One is YouTube and one is on Twitch. So I'm trying to keep up with two chats. I'm not talking to myself. Or maybe I am. Nobody knows. All right, so in the grid cell, we're gonna have the 8 corners. So we just want to get the values for those. Guess we can create an array. We could probably call it, no, not val. That's not a good name. Or maybe it is. What is it we're measuring? Density or something? Thanks for the follow, Nova. Thank you, thank you. And welcome to the stream. Let's call it density. And then let's go through all 8 corners. I think we can do this in a procedural way rather than looping and stuff. Let's just add 8 rows, I guess. So when we are in the first cube, yeah, we're gonna have to add, I think, to get to the corners, to the other corners. All right, I'm just gonna follow this guide, have the same numbers. So he starts like that. Okay, 0 is gonna be just on the current position, I think. Density dot append. Noise, I think noise is a better name than noise 3D. Noise generator. Noise generator dot get noise 3D. We can do with a vector. So we have this start base position, and then we just do plus with a vector 3. Yeah, this is going to be clean. Then we can do, in this case, it's just going to be nothing. So let's not add it. Density.append. And then we do 1. So that's going to be, I guess it's up to, maybe it doesn't really matter what I decide that the dimensions are on that picture. Wait. So that is a box like this, and then a box like this. Some mad paint skills here. So let's decide that this is X. This is Z. And this is Y. So then 1 is going to be just plus 1x. And now the cube size is going to become important. That's what we're going to have to use. So we have the same unit. We want to scale it. Get noise 3dv xyz plus vector 3. And then we do a plus on the x. So that's cube size 0, 0. So 0, 1. We can copy paste this row. So we need 8 in total. 1, 2, 3, 4. And then 1, 2, 3, 4. So this is going to be the bottom 4, and this is going to be the top 4. Yeah. All right, so 0, 1, and then 2. That's going to be X and Z, one of each. X and Z. And then I guess it's going to be just Z. Yeah. Cube size, and then 0 here. And I think probably I can just copy paste this. And add the plus 1y. Vector 3, and here it's just going to be 0, cube size 0. And then cube size cube size, cube size. So now this is probably rather getting the grid cell. It's not evaluating it. This should just be get grid cell. That should return city. Maybe it should be called edge density. Yeah, I think that's a better name. What is your streaming schedule plan for the next few days, weeks? Have to go, but I'd like to tune in. Cool, man. It's actually tomorrow I'm going away traveling until Thursday next week. But then usually, I mean, on the weekends I try. Like now in the summer, it's going to be a bit less on the weekends because there's some obligations and plans. But on weekdays, it's I try most evenings to stream for like 2 hours or something. Like in the evenings, European time. Going to Italy. To Pompeii and the Amalfi Coast. Cool, Nova. Thanks so much for tuning in. And welcome to the stream. Okay, now we have the edge density. Density. Now we need to do this magic to get a cube index. Cube index equals get cube index. And then we send in the edge density. And the reason to do this is just to separate the concerns between different functions. I think that's going to make it easier to debug and just maintain this code. All right. Our cube index is 0. I also really like how dedicated you are, even though in one of the streams you didn't manage to get in the light sensor to work. Liked how dedicated you were to try to make it work. Thank you, Arch. Such kind words. Yeah, sometimes, I mean, I think there's probably something you can salvage from most situations. And in that case, I still think, yeah, you're plowing hours into it, and it feels at the end of the session like nothing has been accomplished. But I still think it's a good, you can always, I mean, I think I probably learned something from that session. But yeah, I still haven't figured out the normals, for example. I've probably spent 10 hours or something trying to fix the normals in the big project. One day I'll get it. If wait. If edge density, yeah, I think this is actually better. Better name of the variable. If edge density 0 is under ISO level, I guess this is plus equals. Cube index plus equals 1, plus equals 2, because it's adding on to this bitwise array, or bitwise thing. What kind of things in the game should be random, aside from generation? I don't know. Maybe there can be some Skinner boxes in the game, like some kind of random drops. Some drop tables from enemies or something. Why? Can I do a one-liner? Yeah. Okay, cool. Oops. 3, 4, 5, 6, 7, 8. 1, 2, 3. No, yeah, 1, 2, 3. It's up to 7. 6, 7. 1, 2, 8. 16. 32. 64. 128. Return cube index. Now we're done with that. What's the next step? The vertices of a cut edge. But the scalar values at each vertex, the intersection point P. Still don't understand that part. Okay. Now we need to look this up in the edge table. Get edge. Our edge table value equals get edge table value based on the cube index. It's complaining that the function doesn't exist, yeah. Probably want to write it up here, just so I see better. Oh, just noticed you gained 60 subs since you saw your channel. Thank you. Yeah, that went pretty fast. I'm pretty surprised myself. But I notice it goes up more when I post. I mean, streaming like this is good. Like some people subscribe when I stream, but also posting actual videos is pretty good for that. Like tutorials and just some actual like video content. But it's a balance, like how much time I want to spend on producing videos and how much time I want to spend on creating, like developing games. So I need to strike that balance. Get having both is usually a good thing. Yeah, I think so. Now it's like soon 2 weeks since I posted a video. I'm gonna try to keep it at least one a month. Ideally one per week, but I don't think that's very realistic at the moment. Get edge table value. Cube index. And then can I use these literals in I'm just gonna copy paste this. Let's see if this works with these hex literals. Looks like it. Var edge table equals. Yeah, nice. It compiles. All right. And then when we have the value from the edge table, we want to get the value from the try table. And how long is that table? Using the example earlier where we treat cube index would equal to 8. Edge table 8 gives us this. Edge 2, 3, and 11 are intersected by the ISO surface. Previous step, we calculate the intersecting points 2, 3, and 11. The 8th element in try table is, yeah. But what's the point then of the edge table? With this, we just get the edges that are intersected. Yeah, that's what we get. But the try table gives us the actual triangles. With this, which this time uses the same cube index but allows the vertex sequence to be looked up for as many triangular facets as are necessary to represent the isosurface within the grid cell. There's something here that I still haven't unlocked. The intersection points are now calculated by linear interpolation. The vertices of a cut edge. At each vertex. Oh, okay, I think I get it now. P1 plus ISO value minus V1, P2 minus P1, V2 minus V1. Okay, so this is kind of Yeah, I think I know. So these V's here is the strength of these, or like the density at that point. So depending on the density, I guess here and here maybe? The vertices of a cut edge. Yeah, I think so. So it could be a P1, P2, 3 and 2. And then V1 and V2 would be the values at those positions. And I guess a higher value then would give you the edge would come closer to you. Something like that. But okay. So let us use the try table. This also has 256 values. That's a lot. Try table. Get edge table value. Var get try table. Get triangles. Get triangle table, let's call it. Yeah, triangle table. And this is also using the cube index. Triangles. And by the way, this needs to return, and let's change this to edge table, return edge table cube index. So this is such a beautiful algorithm. Like it feels like such a clean approach. Get triangle table cube index, and then we do the same thing. Var triangle table get triangles, I think it's a better name. Table. Am I using any brackets in this code yet? I don't think so. Let's copy. I'm going to copy this over to VS Code. Just quickly replace this with brackets. Replace that with a bracket, and then replace that with another bracket. Equals. Oh. This is really obfuscating the code with this kind of a big lookup table. By the way, I think this is probably going to be faster if I just have this. I should probably just keep the tables alive in this object from startup instead of creating them at every loop. Yeah, for sure. Var, no, we do that here. Our triangle table array. Or even, let's do this. Initiate triangle table. And then I'll put this in its own function at the bottom of the page so that we don't have to see it. Initiate triangle table. Yeah, awesome. And then we could do the same with the edge table. Initiate edge table. Then here, edge table is also an array. Edge table. Awesome. Turn triangle table. This is so much cleaner now. Cube index. I think we could probably take a stab at rendering this now. Create P0, P1, val0, val1. Okay, I get it now what this is doing. What does this mean? And 256. Edge table. So that's what the edge table is for. The interpolation between the corners. What is vert list? That's all the edges, I think. Oh yeah, okay. It's setting a value for every... Ah, okay, okay. It's setting a position for every edge. And then, okay, I get it now. And then when you look up the tri-table table here, then you get those edge positions from that table that has been created. Makes sense. Okay. Maybe that's overkill for now. I can add it later. Create triangles. Triangles. And this is add interpolation later. To do. Here we are gonna go through this one until we find a -1. And in some cases, I think the first and the last, there's gonna be a -1 for everything. Yeah. So let's do yeah, we do length of triangles. For I range 0 triangles, and then we do 3 steps. I think that's the syntax for that. And if I is -1, break, else. Let's keep a global variable for triangles. Triangle array. Let's call this something that is more specific. Cube triangles. Did I use this anywhere else? Yeah. Cube triangles. Anywhere else? No. But let's do it here too, to be clear. Cube triangles. Yeah. Global triangles. Else. We need a lookup table for the position of every edge. In the cube. Else, let's create a made-up function for now, and then we can replace it later. Or triangle. Empty array. I think I need to instantiate global triangles to be able to append to it. Let's make a packed vector 3. Triangle dot append, and then we'll take get edge position I. Maybe we can even call it get edge vertex or edge vector. No, vertex. I don't know. Which is which again? Vertex versus vector. Geometry, position, and some attributes. Okay, let's call it a vertex. Get edge vertex I, and then I plus 1, I plus 2. I plus 1. And get, I just copied it. I plus 2. And that's going to have it loop through this list. Here it's just going to stop directly. Here it's going to create one triangle, etc. So we could probably actually, let's just do global triangles directly. Global triangles. And then func get edge vertex edge I think for this one I need the base position of the cube. So I'm gonna have to send that in. Var xyz. We're using it twice, so let's create a variable for it. xyz. xyz. All right. So we have that here. Now we can send it in these. Edge and position. Okay. Same here. I should probably have a lookup table again with 12 values in it. Like here, vertless. All right. So that's gonna be edge. We already have edge table, right? So this is, what did he call it? Vert list. That's not a great variable name either. Table. Edge vertex table. We need I need to look at the cube up here to see what they are. All right, so 0 is gonna be on the x-axis, 0.5. So that's gonna be 0.5 times cube size. You need to scale all of them by cube size. This is gonna be 1x, so 1 cube size, and then half a z. All right, yeah, this is gonna have to be vector 3s. Vector 3, x cube size 0, 0, 3, and this is gonna be 1 cube size to the x, and the y is 0 for the first ones, and then the z is gonna be 0.5 times cube size. The second one is gonna be half half an x and 1 whole z. Zero and then a whole z. And the fourth one is going to be 0x and half a z. 0, 0.5 times cube size. That's the first 4. 0, 1, 2, 3. Okay, 4 is up here. So that means, oh yeah, 4, 5, 6, 7. So it's going to be the same thing, but y is going to be 1 for all of them. Cube size, cube size, cube size, cube size. And I think for the rest, it's going to be 7, and then it's going to be 8. Wait, no, these are different actually. Because these are always whole values, not half. On the x and z axes. Axes. So that's different. So y is going to be a half for all of those. And this one is going to be 0x and 0y, 0z. This is going to be 1x, 0z. The next one is going to be 1, 1, I believe. 1, 1, 1, 1. Actually, half, 1, 1. Now I forgot which one I'm at. This one. The third cube size, yeah. And then it's going to be 0x 1 z. 0, 1. What's wrong? Bar. This one we can keep in here. It's small enough, and we're anyway going to replace it by some smart logic, some different logic later. So then we might as well have it in the function. I don't know, I like this 4, 4, 4. Let's keep it like that. All right. Then we just do get edge vertex. It's going to return edge vertex. We just plus these together, or add these together, I think. Edge vertex, edge, plus XYZ. And that's what we get back. Edge vertex table. All right, now I think we're getting close now. So now we have the triangles added to this list, or to this array. Now we need to render them. Render triangles. We can create an array mesh. And I have some code for this from the bigger project where I want to use this eventually. Yeah, this was something I tried this morning. It's very messy, but basically the interface seems to be this. Surface tool, begin, create from array mesh. Yeah, we need an array mesh as well. All right. Array mesh equals array mesh.new. This part we can skip, I think. No, wait. Okay, no, we need this actually. Var arrays equals dot resize dot array max arrays mesh dot array vertex. That's the only one we need in this case for now. And then we'll do array mesh dot add surface from arrays mesh dot primitive triangles and arrays, I think. Yeah. And then we can use the surface tool. Or do I even need to use the surface tool here? I don't know. Huh? Okay. Sounds okay. Okay. This is exciting. We're getting closer. Surface tool new. Guess I can basically copy paste this. ST. We don't need to generate, or I guess why not actually? Why not generate normals? Now we have a mesh. Mesh instance, new mesh. We don't care about materials. Mesh instance. Okay, yeah, we need to create a mesh instance and then set the mesh of that. Okay. Mesh instance equals mesh instance 3d.new. And then mesh instance.mesh equals stmesh. And then we can add this as a child. And that should show it in 3D space. Instance. All right, moment of truth. I mean, if this works now, it's going to be a miracle. Because I haven't compiled, like I haven't run it once. I've just been coding for 1 hour or something. I have followed an article though, but let's see. It almost never happens that it works on the first try. What do you think? No main scene has been defined. Select current. On a null value, get grid cell. Here we go. And I need to add a camera as well. Or I can do at tool, and then it's gonna compile into the 3D space directly, if it works. So get noise 3D on a null value. Get grid cell on a null value. Why is it null? No miracles, yeah. Believe you need to compile game once before tool works. All right. Output. So why is that a null value? Really? It even has a value here. Noise generator is a... Hey, by the way, Jet. Happy Friday to you. And welcome into the stream. This is a... wait. This was... I thought this was saved. Maybe this is the reason. Can't call a method on noise generator. Yeah. This is the downside of setting these things in the UI. Thank you for that, Jet. I had set it, but then it disappeared. Range cannot convert argument 2 from array. Oh, len. Invalid. Get index 12. All right. Edge -1. No. Why would I send edge 12? Get edge vertex. So doesn't it start on 0? It should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How is it possible that this reaches 12? Let's do or I equals. What is length of triangles? Yeah, good question. Get triangles. Yeah, triangle table. It's this. So this is the length. This is 1, 2, 3, or let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What? No, I think, yeah, this is wrong. This should be, I thought about it the wrong way. If it's a points of triangle. Yeah, so this is actually, it shouldn't use those points. These are the edges. So if it's like 0, 8, 3 here, that means that we should make a triangle between the green ones, 0, 8, and 3. So this triangle. So actually, I did this the wrong way. These are not... This shouldn't be I. This should just be actually cube triangles I. And then that checks number 0 up to 12 or up to 11. So that was the mistake. This one. That's 2. Really? Cube, triangles. Yeah, the 16th is, oh wait, if I, same here, cube triangles I equals -1, that means you've come to the end. So there are some examples, like here, where you have 5 triangles. So the 16th value is -1, and then the machine knows to stop. So you always keep going until you're at -1. Okay, this actually compiles. Why is it always returning 2222? That doesn't sound right. "35 errors. Mesh created without vertex array. Vertex array. I guess there's nothing in it then. Something is wrong. Our vertex size equals 0. Yeah, so it's not. All right. No, this is the problem. It's just checking the same thing every time. It should be X, C, Y. Of course. That's why we had just the same thing outputting. Print. Still 35 errors. I mean, it could be that we have just no triangles in this space. Let's try to rule that out by increasing the width to like 20. Oh, 323 errors this time. Oh, okay. I know, I think, what the problem is. Now I'm trying to render the triangles on every cube. That's wrong. Numbers go up. Numbers go vroom. I think this is what I want to do. I want to render them at the end. Okay, trying again. 7. Much better. Surface count. Vertex size is 0. Without vertex array. Okay, so let's see here. This should only be the case if we don't have any edges. So let's debug. Let's check, for example, the cube indices that we get. That's the first step. Print cube index. And we can reduce this a bit. Let's reduce it down to 222 again. All right, so we get some different values here. So there should be some surfaces. So when we have a cube index of 16, why does that not generate any triangles? If cube index is not equal 0, print edge table value ETV get triangles. There is just some magic happening in there. We don't get any output. Yeah, they match with the same. Wait, edge table value. What is that doing again? Edge table. Sure. And what are these values? How high are they? Where's my value? Is there an easy way? But we're anyway not using the edge table. But we are using the triangles. If cube index not equals 0, print CT cube triangles. Yeah, so we should have some triangles created. I mean, this looks good. 1, 2, 3, 1, 2, 3, 1, 2, 3. So it's something else going wrong. It goes wrong further down. Probably in create triangles. Before we render, let's do print global triangles. Okay, so we do have triangles here. Or wait, yeah. We have vertices that should turn into triangles. Something is wrong here then. Yeah, I'm not adding them. I should do that here, I think. Global triangles. I didn't add the triangles. Is that how I did it here? Hey Speed, how's it going? Yeah, what have I done so far? Now I'm debugging why it's not working. But I think I might have found it out. So yeah, I didn't add the vertices. So they were there all along, but I just didn't add them. So let's try now. And there is no camera. Yeah, now we don't get any errors anymore. Awesome. Control-Alt-Delete to see the problem. I don't have those buttons on this computer, unfortunately. I probably wouldn't have done it otherwise either. So let's add a camera. Or can we just do the tool thing now? Okay. So there is probably, oh, look at that. It's there. Nice. Cool. I mean, it looks all right. Oh, okay. Yeah, right. Thank you, Lily. Okay. So what if we do, I don't know, 10. Does anyone know if there's a way to reload the tool? Like just press a button to rerun it? Or do I need to keep closing and opening this? Wow, look at that. It works. Nice. How cool is that? Okay, let's make it bigger. 50, 50. Oh, wait. Why don't we see anything? Oh, that doesn't look as good. I mean, it could be correct. Why are these? I think I'm mixing X. Probably C is up in this algorithm. Okay, let's go again. No. Maybe, I mean, what's going, why is it not? I mean, this could be correct. Just that there is something in here. We can do another seed. Yeah, I think it is working correctly. So it's 50. How does these lengths actually work? It seems to be 50 in the Z direction, and the others are not 50 by 50. If we do 50 here, what do I get? Oh, stop writing. Whoa. All right. I'm gonna stop that. Don't die on me, computer. Oh, wrong button. Yeah. How cool is that? Oh my god. This is amazing. There are no caves yet. But okay, let's make it bigger. So this is 50 by 50. Let's make it like 100 by 100. Or let's make it 200 by 200 in those. I think those are the directions I want to do, 100 by 100. The height doesn't have to be that crazy. All right, that takes some time to calculate. Wow. I mean, there are some artifacts for sure. But are there, like, if you're in this world? I don't think there are. Like, from the inside, everything is there. This is awesome. This is so cool. So I want to make a character that can fly through this, just so we can explore it a bit. Let's do that. Player character. So I think for the bigger game, what we could do is probably generate a surface and then use this to generate what's under the surface. I actually think we get the normals for free with I mean, look at this. This is so beautiful. Wow. I think we get the normals for free with the surface tool. So what's wrong? No shape. That's fine. I just wanted to be able to fly through stuff. But we do need a camera. Camera, 3D. And then I want to give it a script. And I don't want gravity. Let's do on these velocity dot y should be 0 here, so that we don't just jump forever. Move and slide. Okay, let's go. Why don't I see anything current? Okay, maybe this big is overkill for now. Let's do 20, 10, 20. Rounded. Floating. How do I do this? I forgot. I thought it was just about adding a camera, but let's add a body too then. Maybe I don't think that should be it, but collision body, collision shape. Separation ray shape. Capsule. All right, does this work? No. Any ideas in the chat? How am I doing that? Character, add camera. This is in like every guide. Third person controller. Oh, don't. Camera, not giving input to viewport. Godot, screen is array, camera 3D. Just in scene settings, change the main scene where all your work and it will work. To one without a camera. I mean, this is the default scene, right? Okay, F6. Wait, run current scene. Nope, nothing. Nothing. I mean, maybe I need an environment or something. And a directional light. I mean, the camera is just pointing from the player like that. In that direction. Are you saying that maybe... Where is the direction of light? Oh, it's in the wrong direction. Maybe I just didn't... Where do I add the sky? Environment. Sky. Blue. Blue sky. Okay. I need to be able to move, like to turn the character. Let's start by turning this camera. Let's see here. It's on the y-axis, 45. No, I think that's the wrong direction. Yeah, and it's not 45, it's minus 90. Yeah. Okay, cool. Yeah. Now I just need to fix my settings here so I can actually control the character like I want to. Oh, wait, I think I know now. The reason why I just kept... Okay, these are in the wrong directions. Let me get my code from this game. This one. Move and slide. Oh, no. This is the one that goes in. This we can ignore. All right, sensitivity and camera. Const sensitivity. What did I have? Zero. That's ugly. I need to put that up here, of course. Zero, zero, one. Bar camera. And func ready. Camera equals get node camera 3D. Cool. Whoa. This is weird. What's going on here? Whoa. I'm getting motion sickness. And it's not moving in the right directions either. I think what I need to do is actually move this back. Might feel like I'm starting in the weird, like in the wrong direction, but at least, yeah, this is better. And now the arrows are correct. Can I go? No, I don't go in the direction of the camera. Okay. If input.is action just pressed, dodge velocity.y equals minus jump velocity. Let's do elif, and then if none of them are pressed, velocity.y should be 0. Okay, I think that's good enough. All right, I need to actually set that setting. Input map, dodge, command. And vast. I also need WASD. Forward, backward, left strafe, right strafe. Oops. Okay. Backward. Okay. Left strafe. Okay. Right strafe. Okay. Close. And then I need to set them. It's almost the same, just that there's space here. No. Just gives me 1. Let's do is action pressed. Can I hold it then? Hold it in. Yes, I can. Awesome. Okay, now it works. So now we can explore this a bit. Awesome. Let's do 200 by 100 by 200 again. Wow, that was fast. But why is it so thin? Doesn't feel right. But how cool is this? Look at it. It's so nice. Let's try to change. And then terraforming and walking on it. That's going to be awesome. I want a shape like this again. Finally some progress. Oh, I can't wait to implement this in the bigger game. Wow. Okay, this deep of a world might be a bit overkill. So with the simplex noise, what would be good? All right, there's going to be islands like this. This is almost an island of like floating stuff. I'm sure it's possible to remove those with some kind of algorithm. And this is beautiful. This is so cool. It's amazing. Yeah, over there are some floating islands. I think there's a bit too much air in these caves. Nice. Cozy little cave. Look at that. Wow. Looks like a griffin fighting something. Okay, let's try to play with the values a bit. I think we want less air, more earth. This is the structure we just flew around in. Oops. Yeah. So let's do smaller. 75, 75, 75 should be significantly faster. And then ISO level. What happens if we do minus 0.2? Oh my God. Yeah, seems to be less air, I think. But still, I think too much air. If this is going to be the cave systems under the ground, it should be very little air. But okay, so now let's see where we are at the project. So currently looking, yeah, almost purling noise. Hey Sleepy, welcome. Welcome in. This is simplex noise, 3-dimensional. If it's underground, there should be some pockets of air, but not much. Yeah, that looks better, I think. So when you are digging through the ground, you can find these things. And they look pretty cool. Amazing. I mean, this is so fun. I wish I could spend more time doing this. All right, I think this is good. Maybe I was thinking this could be my world generation project, and then the other one is kind of the game project. So in this one I can work on the terrain thingy. I think how the world generation algorithm should work is that we first get the surface level. Let's say it looks like this. And then for every cube that is under the surface level, so the surface level could be similar algorithm to what we're using now, for now. And then anything that is under the surface, that's gonna use this 3D purling noise for a certain amount of units down. So that the user is free to dig and explore caves. I think that would be fun. I should probably create a repo for this. Or I can just add this code into that project. I think I should merge them. I can work on it in the same project, just that there needs to be different folders then for this. So they should be totally separated in the beginning. What did I call this project? Marching cubes. Why don't I see it here? Oh, it's there. Okay. So take everything except for project.godot. And move it into the sandbox. Into world, let's call it. World creator. Okay, then we close this. And can open up sandbox. World creator main. Wait, main.gd. Oh, fix. Path is, what is it looking for? Main.gd. Character body 3D. Okay. Didn't I fix it? No. Close. Open. Okay, yeah, there it is. All right. Cool. Yeah, this should definitely live in the same project. That asset belongs there. Rust analyzer. Can I close that? Hide. Add marching cubes. Algorithm. Marching cubes. Marching cubes. How's everyone doing this Friday? Everyone feeling fine? So there was one final thing that could be done, but honestly, I don't really see the need for it. There was this, you could make it smoother. I don't know if that's needed. Be right back. It's important to hydrate. There's so much glare from my glasses, like reflecting the green light. But it's good. It kind of hides my blue bags under the ice. Then allowing the player to terraform, that's going to be another beast. But getting that to work is going to feel like magic. Then we're going to be able to walk around on the surface, dig a hole in the ground, create tunnels. It's going to be amazing. Yeah, that's going to be magic. And I think getting there is gonna, like, the first step is gonna be combining a surface with the underlying marching cubes. Wait, we can do an icon here. Should have a better icon for the game. But that's not the focus for today. Be right back again. All right, all right, all right. Welcome to the stream. Welcome, welcome, welcome. Okay. I need to write my thinking now. World gen world creator. Let's do a markdown file here. Let's call it the algorithm. That's cool. Step 1. Create a surface. Surface is ambiguous in this context. Create a surface level above. Run marching. No, marching cubes is not. Gotta separate marching cubes from creating the world. These are two different things. Create surface level above ground. Create underground values. Underground shape. I wonder what's gonna happen if it's simply, let's try to make a surface once, which is just like one layer. Is this really 75 by 75 by 75? Something is wrong, I think. X, Z, Y, X, Z. Oh. Wait, X, Y, Z. But I think that did the same thing, because I moved them in the same way. But let's do like 100 by 100 and then 1, or let's say 3. Is that gonna give me a surface? Oh no. Okay, in this case I just played this scene. Right, I need to change this to be the right names. I don't think I have duck here either. Input map, duck. I mean, this isn't oh, it did, yeah, 100 by 100 by 3. This, what I saw earlier, is not that. But maybe there's stuff that it doesn't go to. Oops, wrong button again. Control R, I think, is current scene. What? Really? Is that all? Okay, let's do this like 0 again. So we have some more stuff. Yeah, okay, this is actually 100 by 100. So no, that's not gonna work as a surface. But yeah, there should be layers or like a stack of operations. That happens here. And how do I store this? Whatever the results of this algorithm is should be stored so that then it can be reproduced in 3 dimensions. Or like in 3-dimensional space. I think the Z should go downwards, not upwards from where we started when we generate this. But anyway, so this is marching cubes on Perlin Noise 3D. Not Perlin Noise, Simplex Noise. Should create another one, which is surface generator. World creator, surface generator. Save. This should also be a tool. Export noise, fast noise light. Export x width. Oh, x length. X should be length. Float. Export y with float. Oh, right, var, var, var. New fast noise. This is okay. And my phone is really dying. Be right back. Right. So this should just create the height map, I think, of the surface. For x in x length. Wait, I might know now why this didn't work. X said Y. Yeah, they were placed on the wrong axis. Y. Set length. It should have been in that order. Height said, I think x should be length. That's like the one-dimensional thing. Then you add a width. You can't have a width without a length. Width. Width. All right. Now, height, if we make height to this 100 by 100, what? What happened? Why did it remove it? Okay. This isn't gonna test it. Let's do like 10. Yeah, cool. So it works now. Nice. That's the reason. or x in x length, or y in no, or z in z width. Thank you, Nova. So it kind of works now. Like I got the marching cubes to work. So they look like this. So it actually renders something. Like if we make it 100 by 100. No, it's going to be too big. Yeah, I mean, let's do... how much is this? 10,000. This is like 1 million cubes. But I think the computer can do it. Oh, wrong. This is the one. Here. Like, it's so cool. It actually worked. This is too much air, so I think the right level of air is if you do like minus 0.3, I think was a good level. Thanks. So where is it? It's up here. So now there's no difference. Wait, this is the same. Okay, there we go. Yeah, so this is what it could be like. Like all of the air now would actually be like that would be let's say dirt or earth or stone, and these would be some pockets in the stone. I think this is more realistic. Yeah, this is much better, I think. Cool. So now I'm trying to create the surface. Yeah, right? That's what I'm thinking. Some kind of... And then giving the player the ability to terraform, to like dig and explore. So here, thinking about how to represent this is in a data structure. Okay, at first, let's create the height map. var height map should be a 2x2 array or a just vector threes with x, y, and z. Wait, there's a lot of errors. Oh, dodge. So what did I call it then? In the player? No, character dodge. Yes. The input map dodge doesn't exist. Maybe I called it duck there. I think duck is a better name than dodge. That's something else. Okay. Height map. Probably a dictionary. So with the coordinates in it. Yeah, I think that makes sense. Height. If x height map x c equals, and here we get the height from the noise map. So we can do noise.get noise 2D xc times export or amplitude float times amplitude. What is it called? Dict? Okay, whatever. Let's do equals right, and then we can print height map. Okay. We can do, let's say 10 by, or let's do just 5 by 5. Amplitude should be 10. All right. Okay. Gave nothing. Oh, because it's not going to be there. else height map x equals an empty dict with c. This could become a variable since we're using it twice. Var height sample height equals this sample height. Okay, let's try again. Cool. So now we have a 5x5 dictionary with some height values, but they are not varying much. They are very small. Let's add some stuff here. Yeah, there are octaves and linearity and stuff. Distortion of the noise. I don't think I want that. No. I wonder what that will look like in the 3D one. Marching cubes. Like if I make this into, let's see, 75 by 75 by 75, and then domain warp enabled. Okay. Marching cubes. Okay, wow. That looks a bit too crazy. Wow. No, that's not good. This is much better. Yeah. Cool. So back to the surface generator. We're getting a very, very small amplitude here. And what are the values I'm getting back here? The original ones. Yeah, they're tiny. Maybe I'm just at a bad spot or something. We do like 20 by 20 to see something more interesting. Not really. I probably want to reuse what I had in the big project for this world generator. And then there's a here some amplitude. We're adding some octaves here. I think I need to do the same thing. Frequency, this is probably an integer. Start octaves, that should also be an integer. That should definitely be an integer. Persistence and lacunarity. So what did I set in world for these? 4. I just had 10 in amplitude. 4 octaves. 2 in lacunarity. 0.5 in persistence. Oh, so persistence should be a float. 0.5. Frequency. I guess, yeah, I'm setting that in here. Yes, okay. So these are kind of different steps. Loop through to create the height, different resolutions. What if we want to do more than just height on the different resolutions? Should there be just one stack or layer per action, and then I can stack them together? I think that's going to be a more interesting approach. It should be like, given a set of coordinates, give me back a world. So this is an example of that. We just loop through these, and then we can do low res heights, 8 res heights, high res heights. So these are like 3 stacks that we do. now. Let's start with the low one. Progress. And then in here, let's use this. So we need to pass the X and Z here. And then, let's see. So if this is low res, this should be the equivalent to a high amplitude, low frequency octave. And that's where we do the X divided by frequency, or in this case, I think it's going to be the same thing as the resolution. So I think there could be a function like this that we reuse. Get height map. And then we need to send the X and the C. Return noise height, so return the noise value times the amplitude. And here we can just do X and C. Is this a useless function? Maybe. Yeah, I think it is. We don't even have the amplitude here. Could potentially send it in. Then it's not entirely useless anymore. So low res could be divided by, let's create a frequency or low res. Noise height. No, all of this we can remove. Wait, no. This needs to live up here still, I think. And this was... And now no, here, else, this is it. Get height on map. Sample X, sample C. And that's what we return. Oh yeah, amplitude. So I think on the low res map, probably want to divide the frequency by no. Or yes. Or no. This is gonna make me take smaller and smaller details. Yeah, I think a higher frequency is gonna zoom in more on the noise. So it's gonna make this thing be on a bigger area. So it's the opposite of the frequency. No, it's not. No. So if I do times frequency, yeah, if I do times frequency, like 1 here, x1, let's say 1 is here, then I have a frequency of 2. Then for x1, the position, I'm going to get it from here instead. But I'm still going to place it here. So it's like zooming in. Yeah, it's like zooming in. Like here. The higher it goes, the more we zoom in. Yeah. And I guess that's actually what I want for the zoom out. And then the other way around, when we have a 0.5 in frequency, position here is going to get this data. So that's going to be like zooming. No, decreasing it is zooming in. Increasing it is zooming out. What the heck? I want to zoom in, so that means I should decrease the frequency. Yeah, there's more details, more granular details, the more you zoom out. And that's going to be the stuff on like the ground eventually. Yeah, and this is going to be the world scale. So, okay. Frequency here could be like 10, and that means the amplitude could be like 100. That's the low res. Then the mid res could be like 5 and 50. And then the high res. Let me just copy paste again. The high res heights could be 1 and 10. These should probably add directly onto the height map plus equaling. Or I can send in the height map in these stack layers. That's also a possibility. Okay, let's do initiate height map. That's just gonna create zeros on all of the positions. So it's gonna create space in memory for it. And also then we can, we don't need to check if the values are already created. Height map equals a dictionary. And then for x in x length, for in range, for z in range, z width, if x in height map, do height map x equals, no, x c 0. Let's just do fill value equals 0. So we don't sprinkle magic numbers across the code. Else height map x equals new dictionary set of value fill value. So that fills it up, initiates the height map, and then we can just set in the height map here. Height map. Height map. X C equals get height from map. Yeah. Cool. Then we can activate these two. Also, and then we print the height map again. And it's not equal, by the way, plus equal. That's very important. Plus equal. No, wrong script. Invalid get index 0 on base nil. Why? Let's print the height map here. Is it initiated? Null. Oh, of course. That returns nothing. There we go. Okay. Yes. What have we set these to? 20 by 20. Okay, that's too much for now. 5 by 5 should be enough. Invalid get index 0. How can that be invalid? 0, 0. Let's see what we have here. Print x c. Wrong one. Yeah, of course, it starts at 0, 0. But why? Why is that not working? Is that working? Index 0. Okay, need to look up some docs. GDScript, dictionary, get item. Yeah, like that. Is it something with the type of the number or something? Index 0. And what does it look like? Yeah, these are integers, right? Yeah, because we're getting it from a loop. Hey, Jason. Thanks. Click the height map in the debugger locals thing. What is the debugger locals thing? Hey. You mean this? Oh. Wow, I did not know that. I mean, I've been looking here so many times, but this is so cool. So there is a 0, and then another 0. Oh, wait. Is it because we're sending in a height map and we have a global height map. Maybe that's why. Maybe they get mixed up. It shouldn't matter because they reference the same thing. No, I think I'm gonna do it the other way around. Let's call this something else. Global height map or something. But this is gonna initiate height map, so that's not gonna work. All right. All right, so now, I mean, maybe the naming isn't perfect, but now we have a global one and then we have a local one. Oh, so the members are the big ones, like the global ones. No idea. I thought that would show something useful, but it didn't. Yeah, unlucky. I mean, this is, thank you so much for telling me though. I didn't know this. This is gonna speed up my debugging time by a lot, I think. Continue. It's such a weird error. Invalid get index 0 on base dictionary. And when we look at it, the only thing I can think about is that these are floats and there are ints in the dictionary. Let's make the dictionary. But no, these are also integers. Let's be explicit about it. I want them to be floats. Var x float equals, I don't know if this is how to cast in this language. Yeah, that was it. That's such a sneaky error. It's a data type issue. And it didn't even say it. Because it was just not the same value. Even though they look the same. Yeah, just looked like a normal 0. Maybe that should be improved, that error. Maybe it should say cannot find 0 integer or something to be more clear about it. I don't know. Or like had. No, but I don't think. Maybe that's not. I don't know. Maybe that's not useful. So let's be explicit about that here as well. And isn't it even stranger that here in this loop we got integers? Or no, here we got floats for x and c. And down here in this loop, x and c became integers. Oh, wait. In range. But here I'm just doing in x length. I'm not doing in range. I don't even know how that works then. That's the problem. That's where it comes from. But I want them to be floats. C float. I agree, it should display 0.0. As a literal. Var x float, var c float. All right, height map is still a bit underwhelming. These are the y. These are the y values. I want there to be a lot more of a difference between the tops, between the peaks and the valleys. Not really using, but okay, yeah, maybe this is actually reasonable because this is just a 5 by 5 grid. If we do, let's say 100 by 100, let's just sample some values. Yeah, okay, this is actually pretty good. -12, -4, -3, yeah, this is good. I think this is good. Probably want to use the amplitude. The octaves I'm not using. Persistence, linearity I'm not using. But probably the amplitude. No, that should be a stack by stack thing. Let's try to start thinking in stacks and frequencies for the resolution. Okay, so this now gives us a height map. Everything is kind of negative. Or, okay, not everything. Definitely not everything. So much data being stored in these floats. I don't need this much precision. Like, this would be enough. Or maybe this, but not more. It's like 9 decimals too much. And maybe this is not even all. All right, so going back. So I want to combine this height map with this marching cubes thing. This one. So this is a 3D noise map that we run marching cubes over to create a mesh. It's pretty cool. And I want to use that to create the underground, the cave system under the world, and the height map to create the surface. How do I combine this data? What I could do, actually, is to run maybe it's not harder than that. Like, if the surface level goes like this, I know where this number, I know that this is like a 0, and this is like a 2. And then for every, I don't know, like the grid, let's say this is 0.5 or something. And then for every whole unit below, I just check a noise map. A noise, noise map, like, oh, here we have a value of some sort. Here we have another value, minus 0.5, and that's where the caves start. I could, and I just then create like a stack going downwards with data values. And then when we run marching cubes on top of this, I just give, yes, that's how it's going to work. So we're going to go down below and fill in with a noise map. And we're going to go up above and fill it with air. And then I think directly below, let's say 2 units down or something, we just fill it with dirt or earth or rocks or whatever. And then we can just run marching cubes on all of it. That should bring a surface that you can walk on. And then when we have terraforming, you should be able to dig down into the ground and explore. Yeah, I think that should work. I don't see why not. Surface plus terraforming. Save. Yeah, I'm super excited to continue with this. This was such a great session. 4.5 hours. So it's a good one, long one. And also actually managed to reproduce this paper like this article's marching cubes algorithm. There's only one feature I'm not doing, and that's the interpolation to have more smooth triangles, like they're not always going from the middle of the edge. But for now, I don't think I need it. So yeah, this is super cool. Really looking forward to continue this. And it feels good to actually break down the project. Like earlier, I can show you for everyone new in the stream. And welcome, by the way, everyone. So for everyone new, like this is what it used to look like. Or I can just do command. Let's see here. Display. There's a risk the computer will die now. There's a bug, it seems, on... oh no, I was refactoring it this morning, so it's not working. Hold on. Chunk. I think it's in here. I destroyed it. And experimental. Can I just move this over to another file for now? Oops. So hang on, I'm gonna show this. Is it not saving? Control save. And this should then take stmesh. Does that compile? No, wrong thing. Command B. Yeah, okay, so here we go. So this is kind of the previous project, and in it also, or like this is the project that everything is gonna end up on in the end. And there's also some objects that are normally spawning that I removed for the debugging. There used to be monsters spawning, but now there's only like trees. I don't know, the numbers are different since I changed the filter kind of. But yeah, this is what the surface looks like at the moment. So you have trees, different sizes, different rotations, they sway in the air a bit. Yeah. And you can cut them. Oops. And you can build stuff. Yeah, too bad the monsters aren't here. It would be nice to show them. But yeah, I haven't queue free. Okay, there's some bug here. But anyway, so that's just to give a bigger picture of the project as a whole. Way further than you. So what are you working on, Nova? Jason, tinkering on a game, but my whole world is a 10 meter by 10 meter plane. Okay, nice. And what kind of game is that? .3D kinematic character controller. Nice. What do you mean by 3D kinematic? Are you using Godot? Godot 4. Yeah, but everyone starts somewhere. I started like... What is it now? Okay, yeah, March. That is a while ago now. 2 months. 2.5 months. All right. TFT, Team Fight Tactics, or what is it? It's like this auto chess, right? I played that game quite a bit on the phone. They're fun. Nice. All right. Anyway, I think I'm gonna stop the stream here. Gotta get up relatively early tomorrow. Is anyone... Wait, using Godot 4, trying to get a character controller working using root motion. What is root motion? World first. Yeah. Let's see. I'll raid this guy. Oh, animation and stuff. All right, yeah. Let me check before I rate this guy. What is root motion? There's so many things you can like dig down to in these game engines. So many details. Computer. Every frame a change in the root transform is computed. Fine point CGI. Yeah, I've seen some tutorials about him. So what it's making the animations look more real.
With Fine Point CGI, and today we're going to talk about how to use root motion. We come in here and we install this to one. Is much like what you would expect in most games. Now you'll notice that our character just grab this and say, if our button is on that vaulting system as well, that'll probably just be a quick update. It'll probably be like a 5-second video, hopefully, although for me a 5-second video means about 20 minutes. But
so what, this is actually moving the character.
We're setting our direction to direction our rotated normalized. So if we come up here, we basically just check to see if our mouse button is pressed. Then we can basically just say, hey,
that's
it's
cool.
Pressed far off the distance for it to work.
Oh, that's, I think I saw someone doing something like that. Yeah, it is. But that was like when he moved the character, like if it was running and then he stopped, it was like gliding. Do you think that's root motion? I'm gonna have to read up about this. This is something I still have to do. My character still looks like a yeah, it's still very, yeah, it's nothing. It looks like this. So I haven't focused on the player at all. Oh, no. Animations hint to the game where the characters should go. Oh, thank you so much for the follow, man. Thank you. All right. I'll raid a favorite of mine. Guy I like. Griffing, I think his name is. CM Griffing. All right. Thank you guys for tuning in, and welcome to all the first timers. See you next time. Bye-bye. Cheers.
Doing some Godot stuff. Nice.